Okay, so basically what the question is saying that is that we have a sphere and we have a spherical shell. And these two are both conducting. So this one is R1, this one is R2, and this one is R3. Inside anything that is conductive, E is equal 0. So let's just say R. If R is smaller than R1, then E is equal to 0. If R is between R1 and R2, then we need to calculate it. The way that we calculate it, for example, this one is RR, for example. Imagine this is a sphere. I know it doesn't look that much like a sphere, but just like imagine this is a sphere. This looks a little bit better. So basically the way that we can do it is that we know the flux that goes through it is equal to E dot d of A, the integral of that, and it's equal to the Q over epsilon naught. And the E is equal at every single place because the E is not connected to d of A basically. So what we can do is just say it's equal to E integral of d of A, and we already know that the d of A is 4 pi r squared because it's a sphere. So it's gonna be E times 4 pi r squared. And we also know Q because it already says that the solid sphere has this much charge. So what we can do for finding E is literally to just say Q over 4 pi r squared epsilon naught, which is equal to KQ r squared. And also, in case you didn't know, K is equal to 1 over 4 pi epsilon naught. So this is just like the E that we have. I'm just gonna write it here, KQ over r squared. And now we go to the next phase, which is between R2 and R3. So if R is between them, then E is equal to again 0. Why? Again, because this is conducting and the electric field inside the conductor has to be 0. Sorry, anyways, it doesn't matter that much. And for the last part, we have to say R is bigger than R3. In that case, again, the Q that we need to find is equal to this Q, which is Q1. Let me just write Q1 here. And this Q, which is Q2. So, like, we're gonna have a sphere that is, like, bigger than R3. I'm just gonna move these. So this is the sphere that we have, and the radius of this sphere is bigger than R3. So basically what we need to do is that we find the Q inside this sphere, which is equal to Q2 plus Q1. And over epsilon naught is equal to the flux. And this flux is equal to E dot integral of d of A, which we already know because it's a sphere again. So it's gonna be 4 pi r squared. So this one is gonna be Q2 plus Q1 4 pi r squared epsilon naught, which is equal to K Q2 plus Q1 over r squared. Just gonna write it here. K Q1 plus Q2 over r squared. So this is the way that we just approach this kind of questions.